Well, there are 4 scenarios if you have 2 lines given in space. The first one, let me jump to this one here, is called coincident. Coincident means they are the same line. So line 1 and line 2 are the same line, so every point is overlapping. There are infinite number of solutions, right? If I give you 2 equations and they're identical, well, then they are coincident. They're the same line. I can give you 2 lines where they are parallel, and we are used to this idea because we learned this in grade 9. So they have the same slope, but different y-intercept. Now, we don't say same slope. So here we would say same direction, right? Same direction, but the points are different. Same direction, but points are different. So that's easy to understand because you can just draw 2 lines, right? Or you hold 2 pencils up right now, right? If the 2 pencils are the same pencil, well, you have 1 single line only. Or if the 2 pencils are parallel, well, they're never going to intersect. No points of intersection. So usually those 2 cases are not something we put on a test much because they're easy to show. And it's easy to tell that, oh, they are the same line. What's different about 3D is that these 2 scenarios, case 1 and case 4. Case 1 and case 4 are a little tricky. Maybe I'll show you the video here. You can see what I'm doing. If I have 2 pencils here, right? As you can see, they're touching. Right? So this is a point of intersection. We have 2 lines in 3D and it's touching. There's a point of intersection. This is the first scenario. Intersecting lines at a particular point. POI, grade 9, grade 10 material, right? Solving for a point of intersection between 2 lines, right? In grade 9 and 10 is 2D. So we do substitution and elimination. In 3D, it's going to be a little bit more tougher, which we'll cover it. It's not too bad. But there is another scenario which is new, and this is new for 3D. Right? I have 2 lines here. Now, from your point of view, is this 2 lines intersecting or not? I need to cover it so they can see. Right? Now, you may think that these 2 lines, these 2 pens are intersecting here. Right? But if I turn sideways, you see it's not. They're not touching. You see how here by looking at the front view, right? You're looking straight right into the screen. It looks like they're touching and intersecting. But if I've turned you to side view, they're not. Right? They're not touching here. You see there's a gap between them. Not the front view, but the side view, there's a gap. And this is what we talk about in 3D, that there's a extra scenario. In addition to being the 2 lines being the same or parallel and not touching, you can have intersecting lines, even though their directions are different. Or you can have what we call skew lines, that they're not parallel, but they actually do not intersect as well. And what's tricky is how do I distinguish between those 2? Because 2 of the 3 coordinates are going to be equal in this particular scenario. It's just the 3rd coordinate are not overlapping. Will I show you an example? Of course I will show you. I'll show you an example of this and I'll show you an example of that. Okay. I just did. Okay. So again, if I touch the 2, right, you can see that they're touching. This is intersection. If I don't touch, this is skew. If you look at it from your point of view and I turn it like this way, it seems like they're intersecting. But when I turn it this way, they're not. You can tell that they're not touching. Right? So anytime 2 lines that's not touching, but they are not parallel, then it's called a skew line. Right? You can be like this. You see a big gap. Oops, big gap. They're not parallel to each other, but they're not touching. Right? There's a million examples of that. But if you turn, I turn this way to you, right? Because it's 3D. If I turn it a little bit to you, it may seem like they are touching, but they're not. Okay. Okay, let's look at an example. So to summarize the 4 cases, you have the 2 intersecting lines. One, they are coincident, meaning the 2 lines are identical, right? So that's an easy case. 2 lines are parallel. The vectors, direction vectors are parallel, but the points are not. So that's another easy case. Most commonly asked are the first case and the 4th case, because they are very similar in terms of math. One, there is a intersection. The other, there is no intersection. Skew lines do not exist in 2D, right? In 2D, you don't have skew lines. It's only in 3D. All right, so let's look at this particular example. We will give you 2 lines. You're given 2 lines, and you're asked to find whether there is a point of intersection or not. They're not going to tell you, right? So you have to solve the question to decide if they actually are meeting, intersecting at a point, or no, they're not meeting at a point, therefore they're skewed. First thing we need to check is we look at the direction vectors. So for line 1, it's -3, 1, 4. Maybe I'll rewrite it this way. -3, 1, 4 plus -1, 1, 4 times the letter S. So you can tell this is a point, and that's the direction for line 1. What about line 2? Line 2 is R is equal to 1, 4, 6. -6, -1, 6 times T. And this is a point. And here is a direction. The reason they use S for one and T for the other, because they don't want to use the same letter, right? Because the time for this particular is going to be the different time, right? They're not saying they start at the same time. So it's just a parameter for the first letter, first line. This is the parameters for the second line, right? So S is like T, exactly. You can use other letters as well. They don't use the same letters for all the equations. Then it's confusing, right? Like, which T are we talking about? So what we have here is we have equation of 2 lines. We have one line, we have another line, and we don't know if all 3 coordinates are equal. If all 3 coordinates are equal, then they intersect. If only 2 of the 3 coordinates are equal, then they're skewed, right? So we don't know which one it is, but we're going to try to solve for it. We're going to assume it's actually a point of intersection because they are very similar to each other. So the process here is you're going to let x equal x, y equal y, z equal z. So for line 1, the x values is going to equal to the line 2 x values. If they all equal to each other, you're going to have a point of intersection. If they don't equal to each other, then, well, one of them does not equal to each other, not everything is going to equal to each other, then they don't intersect, the skew line. So here's the process. 2 steps. It's actually not too bad. Step number 1. Turn both lines into parametric equation. Turn both lines, L1 and L2, into parametric equation. It's component form. Because we want to make x equal x, y equal y, z equal z. The only way we can do that is we turn both equations into parametric equation. Because a vector equation, we can't equate them. We can only equate them if I can make this into x and that into x and make the x equal to each other. So for the first line, the one in blue, x is -3 minus s. Y is 1 plus s. And z is 4 plus 4s. For the second line, x is equal to 1 minus 6t, y is equal to 4 minus t, and z is equal to 6 plus 6t. You see, I turned both equations into the component form or parametric equation. So I'm going to drag it down and put it here. Going to make them side by side. This is line 1. This is line 2. And if they intersect, right? If they intersect, then the x value must equal this x value. That's what I mean by point of intersection. They are equal to each other, right? They are equal to each other. So therefore, I have 3 equations. Equation number 1, equation number 2, equation number 3. The first equation is -3 minus s is equal to 1 minus 6t, because they're both the x coordinate. The second equation is going to be 1 plus s, which is going to equal to 4 minus t. Again, that's the y coordinate. The z coordinate is 4 plus 4s equal 6 plus 6t. I want to use a red. I want to color code it. 6 plus 6t. So now we have 3 equations and 2 unknowns. And if you did really well in grade 10, you know that in order to solve 2 variables, you need 2 equations. So use any 2 equations to solve for s and t. So you can pick any of the 2 equations to use, right? It doesn't really matter which one you pick. I am going to pick 1 and 2. Why? Because I see a minus s and I see a plus s. I know if I add the 2 equations up, they will eliminate s. Elimination or substitution. If they use the same variable, you can change one to s and the other to t. Okay? Again, they're just giving you 2 pathways using t as time. Right? They're just parameters. They're just letters. Okay? So here, what we have here is I'm going to do elimination substitution, which is grade 10. I'm going to add the first 2 equations, 1 plus 2. What's going to happen when I add those 2 equations? I'm going to get -2 plus 0, because minus s plus s is 0, equal 5 minus 7t. Bring the 5 to this side, t equals to 1. Right? We solve for t. And then I'm going to sub this into any one of those 3 equations to solve for the value of s. So let's say I sub into 2. Second equation says 1 plus s is equal to 4 minus t. 1 plus s is equal to 4 minus t. Now, if t is equal to 1, this is 3, and s is equal to 2. Right? S is equal to 2. T equals to 1, s equals to 2. Now we're going to check and see if it's intersection or skew. So t is going to equal to 1, and s is going to equal to 2. Actually, did I use different colors? Yeah, okay, so I need to switch. S is the one that's blue. Blue, come on, I'm not colorblind. And T is the one that's black. Okay, so copy, paste. Okay, so now I'm going to substitute the value of S and T back into the two separate lines to see if it's the same point or not. So when S equals to 2, X is going to be, not S, X is equal to negative S3 minus S, that's negative 5. Y is equal to 1 plus 2, which is 3. Z is equal to 4 plus 4 times 2, that's going to be 12. So after 2 seconds, the first line is at negative 5, 3, and 12. Okay, what about the second line when t equals to 1? When t equals to 1, X is equal to 1 minus 6. Well, that's negative 5. When t equals to 1, 4 minus 1 is equal to 3. And when t equals to 1, 6 plus 6 is equal to 12. Now, what do you see? It's the same. Therefore, the point of intersection is at negative 5, 3, and 12, which means for the first line, the blue line, it's going to reach that point after 2 seconds. Right? After 2 seconds, it's going to reach that point. For the first line, the other second line, sorry, not the second line, the black line here, it's going to reach that point after 1 second. Right? So they will meet, the two pathway is going to meet right here. And they intersect at negative 5, 3, and 12. Okay, so again, go back. I'll go through my steps once more. You're given 2 lines and you're asked to find if they have any point of intersection, like do they meet or not. So the first step you do is you turn both lines into a parametric equation. Right? If it's already in a parametric equation form, great. Right? You don't even have to do that first step. But if you don't have it in a parametric equation form, then you have to rewrite it into the 3 components. Now you have 3 equations. You have the x coordinate component, you have the y component, and you have the z component. Well, you only have 2 variables, so you don't need all 3 equations to solve for 2 variables. So you're going to pick any 2. It doesn't matter which 2 you pick. Pick any 2 equations and do elimination or substitution, something you learned back in grade 10, to solve for the variables. So here, I use elimination because I see a negative s and a plus s. I add this 2 equations, I'm going to eliminate the letter s. So I get negative 2 equal 5 minus 7t and solve for the value of t. Once you get the value of t, you sub into any of those 3 equations to solve for the value of s. Right? Substitution, elimination. You did this back in grade 10. So once you solve for each of those 2 variables, then you're going to sub it back into the equation to see if they are actually meeting, like are they all the same, or one of the variables not the same. So what I did here, I put 2 into the first line, 1 into the second line, and I see that they all have the same coordinates, meaning the 2 pathways meet at negative 5, 3, and 12. Okay, let's do one more example. We'll go through the same process again. Again, if you're given the same variable, it just means they both are talking about time. You can change one of them to S. You can change both of them to A and B. Whatever you want to do, it's up to you. Okay, they're just variables. So here you have 2 lines. Line 1 it's already in a parametric form. X is -1 plus S, Y is 3 plus 4S, and Z is equal to 6 plus 5S. You have a second line. X is equal to 4 minus T, Y equals 17 plus 2T, and Z equals 30 minus 5T. If they intersect, then the X must equal to the X, the Y must equal to the Y, and the Z must equal to the Z. Second step. We're going to pick two equations. We're going to see if we can solve them. So the first equation is -1 plus S equal 4 minus T. Second equation is 3 plus 4S equals 17 plus 2T. Third equation is 6 plus 5S equal 30 minus 5T. Equation number 1, equation number 2, equation number 3. Now, nothing is going to work directly, but here I have negative T, I have 2T. So I'm going to multiply the first equation by 2. Again, whichever equation you want to substitute or eliminate, it's entirely up to you, right? This is grade 10 material. We're not going to go too much detail into how to do elimination substitution. So I double the first equation, and then I'm going to add the second equation. Okay, what happened if I do that? The T is going to cancel out. So what's left is -2 plus 3, that's going to be 1, 4S plus 2S, that's 6S, 8 plus 17 is 25. Bring the 1 over, S is equal to 4. Once I have one of the letters, I can solve for the other letter by substituting any one of the three equations. The first equation seems to be a lot simpler, so I'm going to sub S equal to 4 into the first equation. So this becomes -1 plus 4 is equal to 4 minus T. -1 plus 4 equal 4 minus T. -1 plus 4 equal 4 minus T. So I solve for T. I'm going to bring the T to the left. Bring those to the right. That's like 3. Bring the 3. 4 minus 3 is 1. So I got S equals to 4. T equals to 1. So now the third step, I'm going to sub those two back into each of the two equations to see if they are at the same point or not. So going back all the way up top, my first line, oops, come on, copy and paste. This is my first line, my second line. This is my second line. Okay. What happens when S equals to 4? Well, and when S equals to 4, X is equal to -1 plus 4. Well, that's 3. Y is equal to 3 plus 4 times 4. That's 16 plus 3, that's 19. The Z coordinate is 6 plus 5 times 4. That's 26. Okay. Second line, X is equal to 4 minus T. T is 1. 4 minus 1, that's 3. Y is equal to 17 plus 2 times 1. That's 19. And Z is going to equal to 30 minus 5 times 1. 30 minus 5 times 1 is 25. Now, if you compare the two, what do you see? Well, the Z coordinate is not the same. They don't equal to each other. The X coordinate and Y coordinate looks fine, but the Z coordinate is not right. So if you look at it from a top view, it may seem like two lines are intersecting. But if you look at it from a side view, you're going to have two of the variables being the same, but the third variable, it's actually not touching, right? It's not touching. The line, like one is at 26 and the other is at 25. So if you look at the top, it may seem like they're overlapping, but if you look at the side, they are not touching. One of the coordinates are not the same. So we say, therefore, these two lines are skew, and they are not going to have a point of intersection. They're not touching. And you see the math between the two examples are identical. There is not a thing that's different in terms of the steps. We turn them into parametric equations, both examples, and we make them equal to each other. X, Y, Z, you have three equations. X, Y, Z, you have three equations. Then we pick any of the two equations and we do elimination or substitution. Personally, I like elimination, but if you are used to substitution, you can always rearrange the equation, S equals something, and then sub into the next equation, right? That's grade 10 material. Sub or eliminate, and you'll be able to solve for one of the variables and the second variable. So here we solve S and T. Here we solve the value of S and T. That's the second step. Once you have the values of S and T, you're going to sub it back into the two lines separately to see if they are the same point or not, right? Sub and see if it's actually a point of intersection or if the two lines actually do not meet. So you sub the S value into the first line, the T value into the second line, and see if they're the same. If they're the same, that means the pathway meet at this particular point. In the other case, we sub into the two equations and realize one of the coordinates are not the same. Anytime one of the three coordinates are not the same, or another word, if all three of them are not identical, right? Any one of three is not identical, then it's skewed. They are not actually touching.